Hi all. In last class we had discussed what is RTL, register transfer logic, what is micro operation, what we meant by control function, what is the use of registers, and first micro operation, that is inter-register transfer. In this class we can study next type of micro operations. One is arithmetic micro operation, logic micro operation, shift operation, and then conditional control statements. So what do you mean by arithmetic micro operation? Actually, micro operation is a operation that is performed on the data that is present within the register. So second type of micro operation is arithmetic operations, and basic arithmetic operations are add, subtract, complement and shift. If consider an example, f equal to a plus b. It is an arithmetic add operation, and the meaning of this operation is content of the register A is added with content of the register B, and the sum is stored in or transferred to register F. So to implement this type of operation, we require three registers A, B and F, and a digital function that performs the addition operation, such as parallel adder. If f is equal to a minus b, it is a subtract operation. For implementing that operation, we need three registers f, a and b, and subtraction operation by using a parallel adder. Increment micro operation and decrement micro operation is also another type of arithmetic operation, which is symbolized by +1 and -1, which is implemented by using counter. One is up counter and another one is down counter. So this is the basic idea of arithmetic micro operation. Basic arithmetic micro operations are add, subtract, complement, etc., increment and decrement, etc. Consider the statements T2 is equal to A, T2, in T2 A is equal to A plus B, and in T5 A is equal to A plus 1. So one is an addition operation, another one is an increment operation. That is, A register, content of A register is incremented by 1 and is stored in A register. That is the meaning of A equal to A plus 1. And A equal to A plus B means content of register A and content of register B is added, and the result is stored in A register. And what is the meaning of this T2 and T5? Actually, this T2 and T5 is a control function that indicates a timing signal, or it is a timing variable. That means T2 is a timing variable or time in which operation add is performed, and T5 is another timing signal, or it's a timing variable in which initiates increment operation. Clear? So this is the meaning of this statement. T2 and T5 are control functions or timing variable at which that particular operation is performed. And for adder and addition and subtraction operations, we need parallel adders or subtractors. and if we are using a parallel adder for a particular addition operation, it receives input information from register A and B. For implementing multiplication and division, we are using add and shift micro operations for multiplication, and for division we can use a sequence of subtract and shift micro operations. Okay, this is an example of addition and increment function. Register B is the and register A is the, and content of register A and content of B, register B is transferred to parallel adder for performing particular addition function, and the result is stored in register A by using a control function load at T2, and in parallel adder there is an addition operation. That addition operation is an increment because at T5 time the control function is increment. So increment operation is done in parallel adder. So നമ്മൾ പഠിക്കാൻ പോകുന്നത് അടുത്ത മൈക്രോ ഓപ്പറേഷൻ അരിത്തമെറ്റിക് ഓപ്പറേഷൻ ആയിരുന്നു പറഞ്ഞത്. അത് ആഡ്, സബ്ട്രാക്ട്, ഇൻക്രിമെൻറ്റ്, ഡിക്രിമെൻറ്റ്, കോംപ്ലിമെൻറ്റ് എന്നൊക്കെയുള്ളത് അരിത്തമെറ്റിക് മൈക്രോ ഓപ്പറേഷൻസ് ആണ്. സോ ഇവിടെ ഈ ഒരു ഫിഗർ പ്രകാരം ഒരു ഇൻക്രിമെൻറ്റ് ഓപ്പറേഷൻ എങ്ങനെ ഇംപ്ലിമെൻറ്റ് ചെയ്യുന്നു, എ കണ്ടൻറ്റും ബി കണ്ടൻറ്റും എടുത്ത് ആഡറിൽ കൊടുത്തു. ആഡറാണ് ഇൻക്രിമെൻറ്റ് ചെയ്യുന്നത്. ആ റിസൾട്ട് എ രജിസ്റ്ററിലേക്കാണ് സ്റ്റോർ ചെയ്യുന്നത്. അപ്പോൾ രജിസ്റ്ററിലേക്ക് സ്റ്റോർ ചെയ്യണമെങ്കിൽ വി നീഡ് എ കൺട്രോൾ ഫംഗ്ഷൻ, ദാറ്റ് ഇസ് എ ലോഡ് ഫംഗ്ഷൻ. ക്ലിയർ? അതിൻ്റെ ടൈമിംഗ് സിഗ്നലും ഇൻഡിക്കേറ്റ് ചെയ്തിട്ടുണ്ട്. T2 ലോഡാണ് പെർഫോം ചെയ്യുന്നത്, T5 ഇൻക്രിമെൻറ്റ് ചെയ്യുന്നുണ്ട്. ഓക്കെ, this is a summary of arithmetic micro operation. R3 is equal to R1 plus R2 means there is an addition operation. R3 is equal to R1 minus R2, it's a subtraction operation. R2 equal to R2 complement, it's a complement operation. And R2 is equal to R2 complement plus 1, it's a 2's complement of the contents of R2. R3 is equal to R1 plus some 2's complement means it's a subtraction. R1 is equal to R1 plus 1, it's an increment operation. R1 is equal to R1 minus 1, it's a decrement operations. So next type of micro operation is logic micro operations. Actually logic micro operation, it is a type of binary operations for a string of bits stored in the register. A number of bits are stored in the register. If you are applying some binary operations in the on the bits that is present within the register, and they are known as logic micro operations. Examples for logic micro operations: and, or, not, etc., or XOR, etc. If we are using an exclusive OR statement or operations which can be represented by using F is equal to A XOR with B. Okay, here also we can represent timing variable. Okay, these are the summary of logic micro operations. A gives a complement, that means contents of A is complement. All the bits of a register A is complemented and it is stored in register A. Second statement, it's a logic OR operation, A or B. Third one, it's an AND operation, A and B. Next one is a XOR, and shift left and shift right, which is actually included in logic operation. So A is equal to shift left. Shift left is represented by SHL and shift right is represented by SHR. Next one is shift micro operation. It's actually a part of logic operation. It transfers binary information between registers in serial computers, and it's used in parallel computers for arithmetic, logic and control operations. Actually, this shift micro operations which is used to shift the number of bits within a register. Registers are shifted left or right. They are known as shift left micro operation and shift right micro operations. That is SHL and SHR. Actually, it's a part of logic micro operations. Shift left A means one bit is shift to the left of register A, and shift SHR B means one bit is shift to the right of register B. Okay, and this is a normal shift micro operation, that is a logical shift. If we have a data 1001100, if we are applying SHL, that means shift left, one bit is shifted left, and at the LSB part we can add 0. That's a logical shift micro operation. And in circular shift, LSB, if we are using a right shift, LSB, content of LSB is moved on the MSB part. If we are using a left shift, that means circular left shift, content of MSB is shifted to LSB part. That is circular shift. And there is a third case, that is arithmetic shift, which is the shift micro operations which is used for arithmetic purpose. That is, arithmetic shifts must leave the sign bit unchanged because the sign of the number remains the same when it's multiplied or divided by 2. If it is an arithmetic right shift, LSB bit is lost, and we can keep the MSB bit same as that of original data. If we are using an arithmetic left shift, MSB part is lost, we can keep LSB part as 0. That is arithmetic left shift. Next operation, that is a conditional control statements. It actually specifies a control condition by a conditional statement. Example is, if then else statement is a conditional control statement. We have a control function P. So P colon, if condition, then do a particular micro operation or micro operations, else do a particular micro operation or micro operations. This is actually a conditional control statement. If control condition stated within the parenthesis after the word, if it is true, then micro operation enclosed within the parenthesis after the word then is executed. Otherwise, the micro operation listed within after the word else is executed. Consider an example. At time t2, if c equal to 0, then within parenthesis f1 else f0. What it means? It is a conditional control statement. It is equivalent to the following statement, that is c dash t2 at time c dash t2 f equal to 1, at control function c t2 f is equal to 0. That means at time t2, if c equal to 0, that means the value of f is 1. At time t2, if c equal to 1, then f value equal to 0. That is the meaning of this conditional control statement. These are all about arithmetic micro operations, shift operations, logical operations, micro operations, and conditional control statements. Thank you.